What's up, guys? I'm the quickest math tutor, and I will be going over exponent rules that you need to know. The product rule. Okay, so to multiply when two bases are the same, you keep the base and you add the exponents. So as you can see here, these two bases, x, are the same. So we kept the base and we just added these exponents. So let's do an example. Let's say we had x to the 7th times x to the 8th. So we will keep the x because these are the same bases, and we're just going to add these two numbers. So your answer will be x to the 15th. Okay? So the quotient rule. Okay, it's pretty similar to the product rule, but it's kind of the opposite. So to divide when two bases are the same, you write the base and you subtract the exponent. So since these bases are the same, you subtract these exponents. You keep the base and you subtract the exponents. So if we had x to the 3rd and y to the 6th over x and y to the 2nd. So how do we solve this using the quotient rule? So these two bases are the same, so we're going to keep this and we're going to subtract. So this is, if there's no exponent, it's basically just x to the first power, it's just 1. So we're doing 3 minus 1, so that will be 2. So x squared. And now we have these two that are the same. So y is the same base. So 6 minus 2, that gives us 4. So that's our answer. That's the quotient rule. So the zero exponent rule is pretty self-explanatory. So any base except 0 raised to the 0 power is still equal to 1. So if we had like 7, 6, 5, 4, 3 million, doesn't matter what number it is. If we had that to the 0 power, your answer is just 1. Okay? So next we have the power of a product rule. So that's basically when you're just distributing the exponent. Okay? So if we have an example of 6x cubed squared, we're simply just going to distribute the 2. Okay? So 6 to the 2nd power times. So since we already have a 3 here, we're just going to multiply these two exponents. So x 3 times 2, which is just 6. And we can simplify that even more. So 6 squared is 36, x to the 6th power. That's basically it. And, make sure you're able to go backwards, okay? This is a really important rule. Many people mess this up, or they simply just forget to do this. They forget about this. So this is really important. So next we have power of a quotient rule. So the power of a quotient rule, it's also basically like power of a product rule, except you're just distributing the exponent over a fraction, So if we had like x over y squared and we cubed it, how would we use the power of a quotient rule to solve or simplify this problem? So first, we're just going to distribute this exponent here. So x cubed, and then we're going to distribute this exponent right over here. Since we already have a 2, y to the 2nd power, since we already have a 2 there, we're just going to multiply these exponents. So 3 times 2, that's 6, so y to the 6th power. That would be your answer. Okay, next we have a power of a power rule. If you have a term to a certain exponent and outside of these parentheses you have like another exponent, you can simply just multiply them together, which is kind of like what we did right here, See how I multiplied the 3 and a 2 and the 2 right over here? Because it was outside the parentheses, we can still do that. That's power of a power rule. So we could simply just, if we had an example like x to the 2nd times 4, we can simplify that using the power of a power rule. We'll keep the variable and we'll just multiply these two exponents. So 2 times 4, well, that's 8, x to the 8th. Pretty simple, right? Now we have a negative exponent. So whenever we have a negative exponent, this negative sign is going to send the entire term under a fraction, okay? If you see a negative exponent, it's going to be sent under a fraction. Okay, so I'm just going to give 2 examples for this. So basically, let's say we had 5 to the negative 2. So since we have a negative symbol over here, we can just put the entire term under a fraction. This negative sign is going to send everything into the fraction, and the exponent will become positive. So we can simplify that as 1 over 25. Okay, but what if we had a question like this, where we had a fraction to the negative power? So how can we simplify this using the negative exponent rule? So basically, all we do is just flip the fraction. So we're just going to do y over x, and your next step to get rid of this negative symbol is we're simply going to distribute the 2. That's it. That's all you do. If you have a fraction to the negative exponent, you still use this negative exponent rule, you know? But it's kind of like the power of a quotient rule where you distribute the exponent. But that's only if you have a fraction to the negative exponent, okay? Okay, so lastly, we have the fraction exponent rule. So that's whenever you have a certain number or variable to a fractional exponent, like a over b. So there's one thing you need to remember, and that's root, and that's power over root. Power over root. That's what you need to memorize. So as you can see, the denominator will become the root of this radical, and the a will become the power. Okay, so what if you had an example like this? 2 to the 5 over 6. So how would you use this fractional exponent rule? So that's simple. Firstly, we need to remember power over root. So this, the numerator, the number on the top of the fraction, will be your power. So this 2 will be to the 5th power, and the root will be 6. The root is what's under the fractions. So we're going to put 6, a radical. That's basically it. That's all you need to do. So thank you for watching. I hope this helped you. Please make sure to like and subscribe.